All right, so we're talking about 5.1, graphing quadratics. We have different parts of a quadratic. Graph of a quadratic is called a parabola. It's spelled parabola, but we say parabola. Every parabola has a vertex. The vertex is where the parabola changes from going down, 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 down. It hits the lowest point and it starts to go back up. It's not always the lowest point though, because some parabolas look like this, right? So the parabola goes up, 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 it hits that point and then it starts going back down. There would be the vertex. There's parabolas that open up left and right, but we're not talking about them in analytic geometry. Running right down the middle of all parabolas is the axis of symmetry. The axis of symmetry cuts the parabola exactly in half, okay? The parabola, you would say, is symmetrical about the axis of symmetry, meaning that this distance here is exactly the same as this distance. Not on my hand-drawn graph so much, but how about this one? Is this one exactly symmetrical? Yes, it is. Okay, this one is exactly symmetrical. So just some basic vocabulary that we need to get out of the way before we start talking about it. All right, first thing is y equals ax squared plus bx plus c. This is called standard form. Standard form of a quadratic is ax squared plus bx plus c. Sometimes this is y equals, what else could it be? Anybody remember function form? Instead of y equals, what might it be? F of x, very good. Could be f of x, it could be y equals, makes no difference. Those are exactly the same for our intent and purposes. Okay? The first learning target, if you look over on the ELT, the first learning target is I can identify A, B, and C of a quadratic expression. So if it's in standard form right here, we need to be able to identify A, there it is, it's a coefficient in front of x squared. There's B in front of the x. B is always in front of the x, and C is the constant. It's the one that doesn't have an x and it doesn't have an x squared. Okay? Write this down. A, B, and C are numbers. They're just numbers. In order for us to find the axis of symmetry and vertex in standard form, we first have to be able to identify A, B, and C. Quickly, easily be able to identify A, B, and C. Okay, so let's do an example. Y equals x squared minus 3x plus 4. What is A? Anybody? 1. It's the coefficient in front of x squared. What's B?
-3.
-3. What's C?
4.
+4. That's it in rocket science. Okay, you're looking at the coefficients and you're figuring out what A, B, and C are. Okay, how about this one? Y equals -6x plus 10x squared minus 42. What's A in this case?
6.
Tricky. What's A in this case?
10.
10. Why is it 10 and not -6? A is with x squared. Right? A is always the coefficient in front of x squared. If I mix them up and put them in a different order, it's not standard form anymore, but you should still be able to identify A, B, and C quickly, accurately. A is 10, B is what? -6, C is what? -42. Okay? A couple more and then we'll move on. Questions on either one of these? Any questions? All right, I'm going to leave that one up. How about this one? Y equals x squared minus 4. What's A in this problem? 1. What's B in this problem?
0.
Is it 0 or is it -4?
0.
It's 0 because there is no x value. Technically, this is x squared plus 0x minus 4. B is 0. And C is -4. Okay? Here's a question. Can A equal 0? Yes or no? Can A equal 0? No, because if A equals 0, you would no longer have a quadratic. You would have a linear equation. So write it down. You could say just simply in your notes, A cannot equal 0, ever. B and C can be 0, but A cannot be 0. All right, are we good on the first learning target there? Identifying A, B, and C, whether it's in standard form or any other form. Okay? Why is that so important? All right, let me turn the video off.